All right, for your calculator portion, you are going to have to know how to find a maximum or minimum value. And you can use the graphing feature on your calculator or in decimals to find the maximum. That's fine. You can also use algebra and just use your calculator to calculate what's going on here. So you have to find the max height, that's the output, and then you have to find the time, that's going to be the input. So to find the vertex, you can just do the opposite of b over 2a. You get 2, and then include your units. So it's 2 seconds. And that would be part B, because part B is asking for the input, that's your x value. The output, you're just going to plug 2 into the original, and you get 64 feet. Okay, you can also, like I said, find that value on the calculator, and you can use that for parts A and B as well. Okay, and then the next calculator question is going to be number 9. So find all the zeros, and then state what your multiplicity is. I'm going to let you check those as well. Okay, so for A, your zeros are negative 3 over 2, negative 1, and plus or minus I root 3. And it says that you are going to identify the number of zeros that you have. Okay, so the total number of zeros is 3 because it is equal to the degree. Okay, and I just let you know that that is according to the fundamental theorem of algebra. Okay, so that's something that you can have in there. All right, so then let's find this. So your first step, if you are finding all the zeros, is to find your x-intercept. So the only x-intercept that you have is negative 1.5. You can find that either using your table, you can use the possible rational roots theorem, but you have to verify with synthetic division. So you have 2, 7, 14, and 12. Make sure you bring down the 2. Okay, so when you multiply, you get negative 3. Okay, when you're multiplying here, this is negative 12 divided by 2, so you get negative 6. So this will be 8, negative 12, yay. And then if it's a quadratic and you can't see anything else, you're going to have to use your quadratic formula. You also have the option here, if you want to divide everything by 2, you can. That just means you're going to be working with smaller numbers. And for this, you can use your calculator. So this is the opposite of b, plus or minus b squared minus 4. A is 1, c is 4. Okay, so 4 minus 16 over 2a. Okay, so you have negative 12 inside there. Over 2. And then if you have I root 12, the perfect square in there is 4, so you have 2I root 3. Divide by 2, divide by 2. Okay, when you are simplifying, if you can divide, divide. If you can simplify the fraction, simplify the fraction. Okay, so your zeros, negative 3 over 2, negative 1 plus or minus I root 3, and then we have our explanation on there. Okay, for this one, I told you that it was, or I don't think I showed you this. 1 multiplicity of 3, you have to have that, plus or minus 5i. And then again, you can just say the total number of zeros is 5 because the zeros are equal to the degree. I really don't want to say the number of zeros are equal to the degree. Okay, so as long as you tell me number of zeros is equal to the degree, you are good. All right, when you graph this, how do you know that there is a multiplicity? How can you tell from looking at the graph? Because you can see the 1. What type of things are you going to look out for? Yeah, so it either touches the graph or there's a bend in the graph that looks like a squiggle, right? Okay, so in this case, we had a squiggle and you couldn't see anything else, right? So if that happens, you do want to make sure that you're trying your multiplicities. Yay. And then you can either factor at this step or, sorry, it's hard for me to talk and math at the same time. Or you can factor at this step. Okay, so if you notice that that was factorable because you had some GCS here, you could absolutely do that. Okay, you could also notice the multiplicity. Use 1, negative 1, 25, negative 25. Okay, that's 0. Okay, so you get x squared plus 25 equals 0. So to solve, subtract it over, take the square root, just don't forget your plus or minus. Okay, so it's 1 with a multiplicity of 3, and then plus or minus 5i. And then when you're writing out your zeros, don't forget this one. So it's 3 total. This is your other 0. Okay? All right, let's look at our graphy graphs here. So I wrote out just some notes to help you. The first one we're going to look at, 11a, there is no x-intercept because they are the zeros of the numerator. If you set the numerator equal to 0 and solve, nothing to solve for. Okay, so if that happens, there's none. You can plug in x is 0 to find your y. This is your fraction. If you found it as a decimal, that's okay too. And again, those are things you can verify with your graph, right? So you can find the y-intercept on your graph. You can check and see, hey, there's no x-intercept. So those are things that you can verify in case you get stuck. Okay, vertical asymptotes. There is no such thing as a vertical asymptote or a vertical intercept. So if you're getting something that is imaginary, do not include it. Imaginary values do not exist on the real graph, which is what this is. Okay, eventually I will show you how to graph imaginary numbers, but not today. Vertical asymptotes should just be x is 2 and negative 2. Horizontal is y equals 0 based on the degrees. This isn't something you have to write down to get full credit for the horizontal. This is just to help you understand where it's coming from as you study for your test. Now, for the domain, we're excluding the vertical asymptotes. For the range, this depends on your situation. So you have a parabola, which means it's less than or equal to the maximum, or in this case, it's greater than the asymptote because it does not cross. You can verify that. If you want to find the minimum value, you will find that everything is above 0. And that could verify it for you if you weren't sure. Okay? Same thing on this side. And I didn't tell you what to round to. On your test, it'll say 100. So if you had negative 5.06, that would be great. Okay, and then let's look at our other graph. So for part B, again, no imaginary values exist on your graph. Okay, so there's no x-intercepts because when we went to solve, we got an imaginary one. Okay, when we solve for the y-intercept, we got negative 2. We can verify that on the graph. The vertical are the zeros of the denominator, so x equals negative 1 and x equals 3. I still have a couple people who are forgetting to specify the x equals, so just make sure you put that on there. That is part of the rubric for the grading, so I would take off half a point if you don't have the lines. And just like we talked about earlier, we do need them because they're lines, and we need to know vertical is x equals and horizontal is y equals. When the degrees of the numerator are the same, we find the leading coefficients and divide. So it should be 3. And then for the domain, we're going to exclude those vertical asymptotes. And then the range for this one, see it does dip below here. So when that happens, how do you find this value? Like, how do you find the lowest value here? What have you guys been doing? Yeah, you can, well, the table would be hard if it's a decimal. Okay. Good. I would use my minimum, and I would make my balance here to here. Because if you say, hey, look between this point and this point, it will give you the lowest point. Okay, and then same thing with this, you got to find the max. The max is sometimes really close to the y-intercept, so you do have to be careful if you're using Desmos. Okay, if you're using the feature on your graphing calculator, then that shouldn't be an issue if you're doing your left bound and right bound. Okay, so I wrote it out to the thousandths and the hundredths, so whichever one, because it didn't tell you what to round to, this test will tell you. Okay, and this situation is it's less than or equal to the max or greater than or equal to the min. All right, and then for number 12, this is going to be on the calculator portion, but you do not need to, really don't need to use your calculator. Okay, so when you are explaining the slant asymptote, okay, it says be specific, like you want to talk about things we mentioned in class. So it is going to have a slant asymptote when the degree of the numerator is exactly one more than the degree of the denominator. Okay, and then I just underlined the key words. So don't just say it's one more. You guys did a really nice job of that on your Google form today where you guys did specify the degree, so keep doing that. Okay, and specifically this is one more. Okay, that's when you have the slant. Okay, this one was a little tricky for the long division, so let's go over how to do that. So if you have your setup, you're doing x cubed, and you can do the plus x squared plus 0x plus 4 to help you if you want to. Okay, now when you're finding what goes here, you're dividing. So you're doing x cubed divided by 2x squared. What helps me is I'll like draw the 1 above it, and then x squared will cancel out with 2 of the x's there, which will just give me 1x over 2, which is the same thing as 1/2 x. And then I'll distribute. So this would be x cubed, 1/2 times 2 is 1. This would be 1/2 x squared. This would be negative 1/2 x. We change the sign, we change the sign, we change the sign. So make sure there's some indicator of your sign change. Okay, and then again, I have negative 1/2 x squared. I'm dividing it by 2x squared. So those are going to cancel. Negative 1/2 divided by 2 is the same thing as multiplying by the reciprocal. So what's the reciprocal of 2? 1/2. That's how we get the negative 1/4. Okay, so when you multiply, you'll get negative 1/2 x squared, negative 1/4 x. Negative times a negative is a positive. Okay, switch the sign, switch the sign, switch the sign. Okay, and then when you're adding those together, times 2 times 2, so you'll have 3/4 x. Okay, this is subtraction, so you'll have plus 15/4. And then when this degree is smaller than this one, you know that you're done. Will you guys do me a favor and just double check that you have that y equals? Okay, so it is an equation of the line, so you want to make sure you have that slant asymptote. Okay, I wrote down this little note. The form of the slant asymptote is always linear. Okay, it's always going to be y equals your quotient. Okay, the quotient is on top when you divide. Okay, so let's go over any other questions you guys have. I'll come around and check in with you.